This lesson explains and reviews percentage growth and decay, which it turns out creates a geometric sequence. So, first off, let's think about an amount growing by 15%. What does that even mean? Well, that means it will increase by an amount equal to 15% of its current value. So here's an example. Suppose a certain college is currently charging $20,000 a year in tuition, and that amount is expected to increase by 15%. To find next year's tuition, the first thing you do is find 15% of 20,000, which I've done right here. So I get 3,000. So that means the tuition is going to go up by 3,000. So I take what it is now, I add the 3,000, and I get the new tuition, 23,000. Turns out we can do this faster in one step. You just multiply by 1.15. That's 1 plus the 15%. The reason this works is when you multiply by just 1, that returns the original amount because the $20,000 isn't going anywhere. And then the 0.5 represents the 15% increase. So you can see here at the bottom, and you can check that with the calculator if you'd like, you get the same answer. Okay, so here's why it's a geometric sequence. If you start with the 20,000, to get the following year's tuition, you multiply by 1.15, which gives you 23,000. To get the year's tuition after that, you multiply by 1.15 again, giving you 26,450. You multiply that by 1.15, and you just keep doing that. And that's what a geometric sequence is. You're starting with a number, and then you keep multiplying by the same thing. So percentage growth creates a geometric sequence. Percentage decay is very similar, except your ratio is now going to be less than 1. So let's dive right into an example. A piano is worth $18,000. It is depreciating. That means losing value at an annual rate of 5%. So this first math problem is figuring out what is 5% of 18,000. Well, it's 900. So that means the 18,000 is going to be decreased by that amount, 900, giving us 17,100. Here's the handy shortcut. This time, since it is decay, not growth, it's 1 minus 0.05 or 0.95. The 1, again, returns the original amount, in this case 18,000, and we're taking away 5% of that, leaving us with 95% of the value. So the geometric sequence starts at 18,000 and repeatedly multiplies by 0.95. So 5% decay turns into a ratio of 0.95. It's really important to me that you can go back and forth between these two different ways of describing it. Percent growth or decay, and then the ratio or multiplier. So anytime it's growth, it's going to be plus, 1 plus, because 1 is the original amount and you're increasing it. Okay, so 5% growth, 1.05, 8%, 1.08, and so on. Now, for decay, all right, let's change this color. For decay, you always end up subtracting from 1. So 1 gives you your original amount, and then you want to take something away from that. So 15% decay, well, 1 minus 15% is 85%. So 85% is left. If 15% goes away, 85% is left. Okay, so for homework, I'm going to, in a moment, advance to the next screen, and you will see a chart to complete and some questions, a word problem below that. All right, so here it is. I want you to figure out if you have a 3% growth rate, I want to know what's the ratio that corresponds to that. Same for 3% decay. 18% growth, 18% decay. And then for these last two on the chart, I'm giving you the ratio and asking you for the percent growth or decay. And then here's a word problem about a house that is appreciating, that means increasing in value at a rate of 5% annually. How much will it be worth in 1 year, in 2 years, 5 years, and 10 years? This is homework number 3. Please have it ready when you come to class tomorrow.